Hello, everybody, and welcome to Handmade Hero. This is the show where we code a complete game live on stream, so long as all of the certificates that certify our certification are continue to be certified and don't expire. Obviously, sometimes you have certificates that expire with their expiration, which causes, of course, the expiration of the certificates that were signed with those certificates, leading to a certificate expiration. At which point, I mean, all bets are off, because without certificates, you would not be able to certify that the certificates that are certifying your certificate are in fact themselves certified, because they could be expired. So one of the things that we like to do on Handmade Hero, obviously, is just remind everyone out there before trying to program anything during the day or evening. Actually, really, it's pretty much time independent, except for, of course, if that time is an expiration date for the certificate, to just go through and check all of your certificates and make sure that the expiration dates on the certificates that you have are not about to expire, because if those certificates expire, then obviously all of the certificates that were certified using those certificates will also themselves expire, which would lead to any certificate certified with the certificates that expired from the expiration of the certificate. Those will also expire. And at that point, mostly what you have is certificates that expired because of previous certificate expirations. Just want to make sure that's clear. And just, I know that sometimes people explain it in a confusing way, so just wanted to put it out there in a way that was really easy to understand. That's just kind of a public service announcement, because if you don't always make sure that you have the certificates that certify the certificates that certify the certificates that you're using for certification, then one of those things could expire, which would lead to expiration. So I'm going to go ahead and just assume that everything's certified today. If we have to recertify some of the certificates that were used for certifying the certification certificate, we can do that, certainly, either way. But for right now, I'm just going to assume that everything's certified, and we'll go from there. And if there's any expirations that happen with Handmade Hero, we'll address them as we go. All right. So yesterday we finished working around some Windows issues that we had, because we were using Windows to extract some font data from TTF files to put them into our asset packing system. The unfortunate aspect of Windows' font extraction that we came across was that, for whatever reason, it doesn't like to anti-alias fonts that are larger than, I think it was, we tested it, 353 pixels high. And so we made a thing that would automatically do downsampling of larger fonts to produce an anti-aliased output. We didn't do anything fancy, just a simple box filter. But we just used that to make sure we could always get anti-alias fonts, even if those fonts happen to be fairly large. Because I don't really know whether we want to use large fonts or not, but I didn't want to leave some kind of mess in there where if we asked for a large font we wouldn't get it or whatever. So we went ahead and did all that, which means we now have the ability to export fonts. What we don't have right now is anything that reads the font text that we output, and that's the only thing stopping us from having completely refreshable art path, meaning we can start from raw inputs and reproduce an entire set of packs that has everything in it that we might want: streaming audio, music, sprite sheet, sound, graphics stuff, whatever, and all the font information, markup, alignment points. We got all that stuff, but we just don't have now a way to read the glyph positioning information. So what we want to do is go in and add that to our import, and then I think we can sort of do some testing of the art packing system to make sure that everything's good where we're at. So I'm going to go into Handmade here. I'm going to go ahead and load everything up. Inside Handmade Hero, the place where this stuff happens is in the import file, handmadeimport.cpp. I would mention just really quickly, we've got, someone was worried on the GitHub. I don't know how to, all right, I don't know how to get this thing going here. Nope, that's not, there it is. If I look at the issues, someone was worried because the space character produced corrupt PNG for the space glyph. What's happening here, you have to remember, we didn't make the ping spec. The ping spec is someone else's spec, and there's some weird issues with it. I replied to it here just so the person would know what's going on. According to the PNG specification, it's actually not legal to make a PNG with a width and height of 0. Now, I don't know why, because that's a valid image, right? Like, if you're trying to specify, hey, what's the image for the space character, right? The answer is there isn't one. There's no data. It's empty, right? So specifying a PNG with a width and height of 0 is the right way to do that. If we were to specify it with a width and height of 1, that would imply that there was a pixel's worth of data, but there isn't, right? So it's not the way I would choose to do it because it's actually not correct. I'm not sure how we would want to solve this problem. We can't really do much about it. And our reader will correctly read this PNG. So it's okay that the width and height would be set to 0 for our purposes. So the only question is, do we want to do something about it for the other programs out there which wouldn't know how to deal with a width and height of 0, and therefore interpret the PNG as corrupted, which is correct according to spec because you're not allowed to do that, but I just don't know what the other option is. One is that we just don't output a glyph for that character. And so what that would mean is that we would literally like compact the table so that there's just no bitmap for it. Like, we have to leave space because we need the spacing information. So it has to be in the table as an actual glyph entry. We just wouldn't have an image for it. I don't know what to make of it. So we have to think about that a little bit. I'll leave this up, but I don't really want to do anything about it just yet because I'm just not sure what the right answer is here. Like I said, we need to leave space for it. And so maybe what we can do is just not output any PNG at all. And then inside the actual text file that we output with all of the glyph information, we'll just leave it as an empty slot that doesn't specify any input bitmap. And then maybe we can just make our text processor understand what to do when it is not given a glyph for one of the slots in the glyph table, right? That's all we got. Okay. So let's go ahead and go into how this is going to work here. I'm going to load up one of those files that we outputted. That's just a test. It's just a test we did of the font code. So if we look in here, you can see all the font bitmaps. There's also an HHT that it outputs, and it looks like this. We haven't thought at all about what we want this to look like. We can obviously totally change this text file to anything we want. And so this is just a rough sketch of what it might be. So what I'd like to do is go through and actually write the reader and then go back to the writer and modify the output to fit what we actually decide to read. Does that make sense? This looks pretty good, but I suspect we need some things up at the front. Like, we'd like to see the glyph count probably, and we'd like to see some of that space information. If I remember correctly, oops, that's not what I wanted. Inside the file format, if you actually go look at what a font has in it, what's going on there? Font, no, there it is. If you actually look at what a font has in it, it's got the glyph, one pass size count point, glyph count, the sender height, and external leading. We're not writing any of that out yet, so I think at a minimum we would want to get that data into our system, and maybe that has to be specified like along with the font, or something like this. So that's what I'd like to do here. If we look at what happens when we're doing our parsing, you can see inside this setup here where we do a parse top level block. You can see us sort of doing the parsing for things like whether it's default, music, sound, block, head, whatever. That needs to have a thing for fonts shoved into it, probably. That's my assumption. But if you actually go look at how this routine works, it kind of argues that we may have to start breaking it apart. And the reason for that is if you look at how we've set it up, pretty much this thing is set up only to really import like one thing at a time, right? So it's going to go read like one file, but we need it to read like lots of files. You know what I'm saying? We need it to check and read a whole set of files. And so really this code right here that reads like a single, a single import, like let's say this right here, or this right here, that code needs to be, we need to be able to call that like multiple times from inside a single block if we're going to do this, right? So I'm not sure exactly how I want to attack this, but what I might do first is try to make it so that maybe we've got separate paths for separate elements here, so that, for example, we know the difference between using, between things that have arrays of alignment points versus things that only have one, or other things like that. And so that we can call like update asset metadata, we would call that for each individual glyph in the font rather than just having one call like it's doing here, and stuff like this, right? So I feel like that's more what we want to do. And in order to do that, what we would need is something that allows us to treat parts of blocks uniformly, such as like the shared information in blocks. So for example, the things that say like what the name is, or what, like we've got sort of these things in blocks that are suitable for default parsing, like author, description, and name, or tags, right? All of that stuff we need, or we want, to be able to be parsed easily by any of our parsing operations. So instead of having to keep everything in the same routine, what I think we might want to do is just have something that handles those externalities. So for example, let's say we took all of this stuff here, and we went down to the end and said, look, this group could maybe all be handled by like a else if handle common fields, right? Like that. And assuming this was handled by common fields, we just do, we just let that handle it. In fact, we could just say, look, if it's not handled by common fields at that point, then we have to issue an error. Then what I can do is pull this stuff out, which starts to get me in a better position for, where am I going here? For being able to make multiple of these, right? Because by getting that code out, now I don't have to leave everything in the same routine. I can just call this from several different routines and not have to worry about the paths diverging, right? So if we had something like this that was like handle common fields, then what I would need to do is say, okay, have a handled here, like that. And then in here I could say handled equals true. So we'll assume we handle it. If nothing gets handled, we'll say handled equals false. Up at the top here where we do handle common fields, we would need to pass it, for example, an HHT fields target to like for it to fill out, right? And that works for most of the things we need, right? So if we had that, we would just need like the tokenizer, the token, and the fields, and most of this stuff would work. So like here, that would work, here would work, here would work. And so the only thing we really have now is the append tags tag list. That's the thing that doesn't work. Well, why don't we just make that part of it, right? Why don't we just make the append tags be part of the fields, and then off we would go, right? I mean, that seems pretty straightforward. And that might allow us to do some other things with tags later on, in addition, maybe, if we wanted to. I'm not sure how sensible that really is as something to do, but, we could see. So if in here we take the tack that maybe HHT fields has that append tags in it, I mean, the first question, right, is like, what is append tags? You can see it's just a tag array with nothing here, right? So, I mean, we could make that part of fields. The other thing we could do is just say, well, maybe that gets passed as well, right? If this were like that, then we could just have append tags and off you go, right? So it seems pretty straightforward for us to be able to do this, and I think that, that right there is an easy enough routine that we can just now call that part of the problem solved. All we would do is pass the, tokenizer token, the append tags, and the fields, right? Now, there's some nuance here. I think we would need the assets for it, so we do need the context, the HHT context passed here, but that's not the end of the world. We obviously already bundled that stuff up for a reason. So we would need one additional field there. That's just so it has some place to talk to the, it can have a route to get to the asset system. So not a big deal there. So I'll just put that in there. And now we've got that extracted as something that we can share for multiple things, right? So what that allows me to do is say, well, okay, now we can start to treat these things potentially as separate paths, right? I could choose, instead of having parse top level block as a thing, I could start to peel off some of these operations, right? So if we look at what happens, for example, with isDefault, what you can see is we're like intentionally avoiding most of the work that we were doing for isDefault. We just say don't do it, right? So I might start by saying, what if we just peeled the default part out of here and said that's no longer a thing. We're gonna handle that back where we called parse top level block. Sorry, typing errors. I'm still split on like my editor. Is different on my work machine now than the one here, which is a little bit crazy. We'll fix that eventually. But it causes me no end to the typing problems. So anyway, on parse top level block, here's where we actually call that code. What I'd rather do, I think, here is just say, okay, let's do a little bit more work here to see whether or not we're setting the default or not, right? So if this thing was the default, then we're going to do one thing. If it's not the default, we're going to do another. And that sets us up to start being able to actually, like, I just realized we could also do this without knowing the HHA, right? So actually, I think this may be actually better than what we were doing, because we don't need the HHA to parse the default block. So actually, this code can do this. And now we can allow default blocks to happen without even having an HHA specified yet, and that's actually more powerful. So that's an improvement over what we had. So if we wanted to do that, what we could do now is called parse default block. And that would allow us, and I guess we don't really even need to pass the token there. That would allow us to make this routine be a little more sensible. So in here we could say, all right, here's what we're doing. We're going to do exactly what we were doing before, where we grab the default fields. We're going to loop over the contents of this block, and then we're going to automatically do the thing that we were only doing on isDefault here, right? So that case goes away, and now we can just do a check on the if parsing for the tokenizer and say, look, assuming that we didn't have any errors, go ahead and set the default fields to whatever we parsed, right? So now I can actually go in here and start pulling out those is default parts. We know that this will never happen now because it doesn't exist as a code path. So in here, what we can do is actually do the block parsing part of this. I'm going to go ahead and just make that out of pieces, if that makes sense. So in parse default block here, we're going to do while parsing. We're going to do exactly this, I think. Right? We need to be able to parse an open brace, though. There it is. And we never rewrite this, so I think it's sufficient, I believe, for us to literally just parse, like to do a copy of everything that exists in the entire token stream, if that makes sense. So pretty much every time through we can do that where we, and in fact I guess I could just do it up here, right? So if we ever hit the close brace, then what we do is require, I don't know, why was that an open brace being required there? I don't know what was going on there, sorry. So we need to require that open brace. I just want to do this copy here where we actually do everything up to the close brace token. In fact, I guess I could do it this way. So this is just letting me say, look, I'm going to parse everything that comes out of here. I'm going to get the tokens sequentially. If I see the close brace, then we're going to finish. And I'm just going to remember where that was so that I can tell this thing to copy all of that into the output if we're rewriting the HHT due to some like edit that our editor did or whatever, right? So then inside here, there isn't any, like none of these things are relevant. So it's only this one that we're doing. So we really just have a close brace, and then if it wasn't the close brace, then we're just going to try to handle any fields. This append tags will be 0 because we're not going to allow tags inside here, and that should do it. I think that's it. So at the end, oh, and I guess we require a semicolon, so I guess we don't even need the close brace here. I guess we can even do this. Like that. So that's even easier, right? That all seems good. So we come in here, we say parse default block, we grab that open brace, we loop through everything that's in here one at a time. If we ever see the close brace, we're done. If we don't, we just assume it's a field. We try to process it that way right up till the end. We don't need this really. This is just a require semicolon, I believe. Because these don't actually ever ask for one, as you can see. So it's really just like every time through the loop we require a semicolon. That's just a hard fact, right? So I think that works. I don't see any other issues with it. So I think that's all we need. And then we just need to make sure that in here we only allow the tags field if there was an append tags. So for example, in here we would do this. Because if append tags doesn't exist, then we don't want to allow anyone to specify a tags field. Because obviously that's not allowed for the person who's calling us, specifically in the default block, right? So that seems like it's all good. Parse default block is supposed to take the token here, I guess, even though we don't really need to pass that. I'm just keeping symmetry with this. And that's all good, right? So now that we've extracted default block, it should also now be possible for us to extract a second block, which is fonts, and call those as a separate processor as well, which is exactly what we want to do because our font parsing is going to be really specialized and weird because it just has a ton of data that other things don't have, and we don't really want to force it through the same path that everyone else was using. So this is parse font block. The exact same things are going to happen here probably, almost certainly, right? It's going to look a lot like this, but the interior of here is going to be completely different. So I think that's all fine. The append tags is actually a thing now that we will have to have. And yeah, so I think we just want to grab that tag array. There it is. I think we just want to do it like this, right? So what we need to do is add the fields here that we want for our font. We can require them in a specific order because these are generated. So if we want this thing to have specific stuff occur in specific order, we can just do that. For example, I don't know if we have a require call for identifiers, but we might. Looks like we don't have a require identifier. I'm going to add that though. Yeah. So right here where we call require token, what I want to do is I want to have a thing that's similar to that. So I want to have a thing that's like require identifier that basically says I want it to be an identifier and I want its value to be this. That way, it's basically just calling it this. And I guess since we're using char stars, we can do it like this because we know that they're char stars always. So inside the tokenizer now, we could just say, I want an identifier. So I want to be able to do require token and get me an identifier for sure. And then what I want to do is say, also this, I think is probably just that. Probably not. So then what I want to do is say, look, if token equals ID match, I think that's all I need, right? Yeah. If this is okay, then we're good, right? If it's not, then we're erroring out. Right? So this way we can say, hey, we needed to see this identifier at this exact time, and we didn't see it. So that's just a hard error. You know, we're not going to go any further. So I think we can do that because now we can just say, look, require identifier, require token, and then get the next token, I guess require token at like a number or whatever, right? And so in here we can say, I know I want to see, what were those things that we had inside our fonts there? You know, I want to see one past highest code point, you know what I mean? Then I want to see an equals sign, and then I want to see the value that we're talking about, just hard-coded. It's got to be these in this order. Just make sure we have them. And then what we'd end up with is a bunch of things that look like this to read fields. So we would say, why can I not get to complete there? There we go. So, you know, I want to see this. Then I want to see this. And then I want to see an integer or whatever, right? So I don't know what the value of that thing is, number. Right? Now what you can see is we're going to do this like a bunch of times, right? So there's, you know, we'd be doing this and stuff. So you can see that this is basically just a template for reading fields. So what I want to do here is say, why don't we just make that be its own thing? I don't know if we want that in necessarily the tokenizer part of things itself, but what we can do is say require field is out here. You pass this to tokenizer. You say what kind of token you wanted the field to be and what the name of it was, right? And that is all we need to do this entire process for every field. We can then require whatever identifier is that you want us, we can require the equals. We can then require the type of token you wanted the field to be, and then we can return it. And all of that just works. So then we can say one past highest code point equals require field. Oh, and you know what? We can also require the semicolon. Okay. So in here we can then require every field that we want really simply with just one line. Say a bunch of those. Don't ask me why I duplicated that word, even though we're only going to have it once. So we can just say, all right, we want to read that. We want to read the glyph count. What else? We got stuff in here. What is it again? Sender, desender. Right, we want that. That. So I should paste them back here as well. Ooh. There we go. And external letting. So at that point, you can see how easy it is for us to just make a template, essentially, that says everything's got to have this stuff at the top. And we know that it's easy to do because our generator does it. Humans don't have to touch it. So this part should just work, right? And we can put those things in there. After those things, you're welcome to put whatever you want, but those have to be there, right? So that seems reasonable. We could instead have gone a different route and said, like, let's put a fixed thing of font data in there or something like that. I don't really care. We could do it either way. I don't really care one way or the other. But here's that, here's this version of it, and we'll see how that goes. All right, so that'll parse the font template for us. If we get past that. Then we can start to do work with it, right? We can create an array of that size to hold the glyphs that come in. We can create a code point table for storing the horizontal advance stuff or other things like that, right? So we can do whatever we want at this point. I think the only thing we really need, though, is this. I think everything else is pretty much not really that important to have up front. And so one way to look at it is we could also make this part of part where we would do the require field thing. We could also make that optional for these, the order optional for these things, and it's only glyph count that has to come first. We could do that later too. I don't know whether we care or not, but it's just something to think about. All right, so when we're done here and we go to actually create this font, we should be able to make one of these that gets kind of stuck into the, in the font file. So we're going to presumably end up in a situation where, we're not setting the default fields anymore. We're parsing the font block here. And so at some point, I'm going to have a thing that's like this, right? And we don't know, how we're going to write that out exactly yet. But we do know that all of this stuff now can get set. So like one past highest code point will equal something, the glyph count will equal something, the ascender height will equal something, the descender height will equal something, right? So I know I'm going to need to fill that out, and I'm going to have to fill that out from these, right? All these things are going to have to be filled out from here. And the way that I'm going to have to do that is the tokenizer has ways of actually getting the value out of it, right? It will have filled these out already. So in theory, I should be able to come through here and say, look, just give me whatever these things are. And probably I'll have to validate them at least a little bit. So we may want to require that they're not negative numbers or whatever else. But otherwise, it's pretty straightforward to just do, oops. There we go. It's pretty straightforward to just pull those out. So that would get us the top part of the font, like the header information of it, right, which says all this stuff. What it doesn't give us is the horizontal advance or the code point data. That's basically which, what each of the code points actually is for each of our glyphs. So we need to be able to write this data out to the file. And in order to write it out to the file, we're going to have to actually produce it ourselves. So I think what we need here is something like this. Once we actually determine that we've got valid data, I mean, to the extent that we think we do, maybe we do something like this, where we say, all right, and I'm going to put the glyph count first here, because these we may move inside, but this one we definitely never would. So then I'm going to say, okay, the glyph count equals the glyph count token S32. When this actually gets specified, we're going to assert that it's like greater than 0, basically, right? So we'll just say like if glyph count token S32 is greater than 0, and maybe we check the parsing level here as well. Looks like we must have lost the sauce bean. Not sure. I heard her food dispenser go off, so at that point, you know she's not going to be sticking around. But I don't know when she actually left. So we've lost puss power. We have no more puss power. We're programming on our own now, which is less good. But what are we going to do? You must persevere. Cat's got to eat sometime. All right. So we're going to see the parsing here. If there were errors in the parse up to this point, then don't bother working on this stuff. Assuming that we see that the glyph count token has a value that seems like it's going to be in range, we'll go ahead and take that, and then we'll try to actually process going forward. So what we would need to do is allocate space for this storage using temporary storage here. So first we would allocate the code points like so. And in here we would say HHA font glyph, right? And we want this many of them. Same thing with this. Got the horizontal advanced table. Not sure why we're still saying R32. And that's going to be a square, right? So that's an n squared table there. That's actually holding for every glyph what every other glyph's advance would be for, if they occur as a pair. That would give us the space we need to store it, and then we can parse each of these. We're effectively looking for a token of type glyph. And if we get that, what we want to see is the code point and the horizontal advance. Just the code point and the bitmap ID for it. If you look here, I think we neglected to specify the code point. So if you look here, we specified the bitmap. We didn't specify, unfortunately, the code point, only the alignment of the bitmap. So we've got 2 out of the 3 things we need. We'll have to add one here, which is literally just a number that is the Unicode code point represented by this particular glyph. Because remember, the glyphs are packed. So if you use a total of 500 code points from the Unicode code set, for a particular font, then there are only 500 glyphs, but there may be a very wide range of code points covered by those 500 glyphs, so that's a very sparse array. So what we want there is just a way of understanding for each glyph in the packed glyph array, what's the actual code point that glyph is mapped to at runtime. When we go here to the glyph processing itself and we parse that stuff, we load that stuff in, what we need to do here is a little bit complicated. We actually have to process the bitmaps separately, so we have to issue a load bitmap, an import bitmap call for every single one of these lines. That's different than what we were doing before. Because remember, what we were doing before is we'd only do for every block 1 file ingest. So files effectively mapped directly to the blocks themselves. But here, each file is mapped to a line. Not a particularly difficult or weird situation. It's just that's what's going on. We also know we have the horizontal advance. So this is a thing that we're going to have to parse an array of numbers out of. So that's another thing we've got to do. And so I'd probably say let's focus on the glyph part of things here, just because that part's a little bit better understood at the moment. And this part is, I should say, I mean the opposite. That part's a little less understood. This is literally just going to be calling the parser this many times, right? This an n squared number of times to get that many integers in, followed by a comma. So that's, you know, that's not big. Oh, hello! Hello! All right, so I guess feeding time is over, and we've restored puss power back to the programming stream, which is very important. Hello, Softbean! How's it going? Do you have opinions on the code? What do you think? Here, let me show you. What do you think of that code right there? Is it good? Do you want to look up at the camera? No. All right, that's fine. You can just do your thing. If you need to type, you can just paw at the keyboard at whatever you think is wrong with it. Just don't shut off the machine. That has happened before. She definitely has shut off my laptop before when I was in the middle of something. And that can be kind of a problem. But, you know, maybe she didn't like what I was doing. It's entirely possible. All right, Softbean. Okay. All right, so we're gonna be cat lap programming here, which is definitely a little bit harder. I don't know if you can see. Okay. Okay, Bean. That's a good girl. She's shedding her undercoat right now, so she is like just literally producing an entire extra cat's worth of fur like every day, which is kind of difficult to manage. I need to get like some more brushes in here so that like I have a brush all for whenever she's around, because she really needs the brushing. She's just shedding so much fur. This happens in the springtime because she does sit in the sun a lot. I think she does do the coat cycle that, you know, an outdoor cat would do, even though she's not an outdoor cat. So it's very okay, baby. Okay. All right. Do you want to program? Do you want to help program? Can you help us program? We got to do this font routine, okay? We're going to do the font. Okay. We're going to do the font routine. You can go look for, why don't you help us by keeping watch on the birds outside, and then we'll write the font routine, and you can check it when we're done and make sure it's good, okay? Okay. Do you need me to put you in your seat? Do you need a lift? Do you need a lift? Yeah? Okay. Come on. There you go. There you go. You want? Nope. All right. Okay. You coming back over? What's the call? So I'm not really sure what Puss wants. Well, she wants to eat my headphone cord, and that's pretty common. But I'm not sure. Do you want to sit there? You want to sit there? Is that good? Okay. Let's just go ahead and see what we can do here. Let's see. We're not getting. Okay. What do you want? What do you want to do? What's going on? You're very cuddly. Yeah? Is there something you need? Is everything okay? You just ate. You just want a nap? What do you want to do? All right. You take care of that, and we're gonna write this glyph import routine here, okay? All right. Like, we gotta parse the glyphs, and those glyphs are gonna give us bitmap code, and the bitmap code needs to be imported separately. So we're gonna have to do like an import glyph kind of a call here, and it's gonna have to take, you know, like a bitmap name, and that's gonna have to get loaded out of the file using the same techniques that we were using before to load things out of the file, which means that we're gonna want to pull that, you know, code that checks to see whether or not something is out of date and, you know, that kind of stuff. We need to make sure that that stuff is happening inside a reusable routine, so for every bitmap we can, you know, actually do that. So we're going to need to pass it the bitmap name, and we're going to have to pass it the align point, like v2, like whatever, you know, we're going to have to pass it this thing, right? And for that, I mean, it's unfortunate, but you know, that we're specifying these align points in two different ways. It's a little bit janky there. So, you know, we may want to write those out a little bit differently. We may want to write those out as the sort of short values that we were using before. I feel like that might be better. So it might be nicer if this was instead an actual align point. So maybe I will force it to be that or something, so that we essentially have, when this comes in, a notion of what the align points are actually going to be. Hard to say, but I'm just going to say, like, I think that's what we want. I don't know. So I think we want to do this, where we just pass the align point in. And maybe, you know, if this were structured to allow many align points for the bitmap, because I don't know how exactly we want to do that, but it would probably look something like this, right? So we have like that one align point, and off it's going to go, but we could pass more align points if we wanted to, something like that. So I don't really know, but let's like sketch it out that way for now, and we'll push forwards through it and see what happens when we actually get there. So we know we have a bitmap file name, right? And that's going to be just this, you know, thing with the ping on it. That's going to go get a path appended to it and then loaded. So that's all fine. But then what we also need here, in addition, is we're going to need to pass like the context, because it's going to need to do a bunch of asset work in order to import that bitmap file name. So I think we need something like that, and then we can read this stuff out as necessary. So we would have like here, you know, a glyph index that we would produce by requiring a token here. So in this case, we would have a number that needs to get read. We would check to see whether that glyph index is in range. So it needs to fit inside the table, right? You know, I just realized one past highest code point we don't actually need to store, because we're going to know that information. We know that like every time we see a code point, we can just make this be one past it. So like in here, when we see the code point, we can just do like if one past highest code point is less than or equal to the code point that we saw, we can just bump it there. You know what I'm saying? So I think we can avoid actually ever specifying that and just track it, since we'll see all the code points when we go to write the thing out, we're done. So these guys here look like they're probably pretty easy to just use directly. So I guess like I really can make this as simple as just requiring the glyph count to come first, right? Everything else looks like we could do this way. And so those allow us to parse these pieces here pretty easily. And these are just like, oh yeah, I need an equal sign. And then I need a number. And that's pretty much it. So I think that's all we need. So I want these to persist outside. So for each one of those, I would just write it up here. Here's the ascender height. Here's the descender height. And here's the external letting. There's the code point. These all get read in. I think that's pretty much it, right? So when we come down through here at the end, then this is going to be like it's going to be exactly the same code. It's just not going to have to do any of those those unpacks there. It can just use them directly because they're just values we track now. So I think we're pretty much good to go. So that means the only requirement for a font is that the glyph count appears first. That means if we wanted to, we could also put that in here somewhere as a different thing if we wanted to. I'm not going to bother right now. I'm just going to say we require that, and we'll just leave it that way. I don't really care. When we actually create these arrays, also, I'm going to, just while we're here, because, you know, might as well, we got to do it at some point. The context has this temp arena. I'm going to use that to just push the memory on here because I don't want it to stick around, right? It's just temporary during processing. So we're going to go ahead and push these arrays on, which allow us to have all the information we need for processing. So then through here, whenever we grab a glyph, we can now say, well, the code points for the glyph equal the code point, right? Whatever that glyph index is. And the horizontal advance, which will come down here, we can just read these in a loop, right? So what we want to do here is say, look, we need to read one horizontal advance for every glyph that there is squared, right? So we've got the, you know, effectively a read index, and we've got glyph count times glyph count. We're going to go through here, reading each of these into the horizontal advance, setting that value. So we know from looking at the actual HHT what that thing will look like. It's essentially just, all right, we've got the horizontal advance token read, so we need to require the equals token now. And then we know that we're just reading numbers. So first we do a require token. Oops. To get the actual number in, and then we do a require token, comma. Right? Now, looking through here, we know that at the end it's actually a semicolon, not a comma. So we really don't want to do that if it's the last one, right? So we only want to do that, you know, if we're in between two. What I could do here is the glyph count times glyph count, say, you know, don't require a token at the end. I don't really want to do that because it's harder to check for. It's just more, you know, typing or storage. What I'd rather do is just, hey, if it's not 0, require the token before you read a number. So that way, right, you can see that this is an easier way to write that. Otherwise, I would have had to say, if it was coming after, I would have said if read index plus 1 is not equal to glyph count times glyph count. It's just more, or save this value and use it, right? You know, it's just, so this is nice and simple. It just keeps it easier. Because that way we know, look, we only require the comma if we already read at least one number. But the first number doesn't need the comma, right? So I think that's all good. That seems fine. So that reads our whole horizontal advance table. So now we just need to finish off reading the glyph. Assuming that the glyph index is okay, then we just need to deal with the code points, the name, bitmap name, you know, that kind of junk, and read, you know, the actual alignment thing here. Now, I want to look just really quickly because I don't remember. I want to go ahead and load into the editor here. What does one of those tag files look like in terms of align points? Here it is. So looking at this, I kind of just want to use the same format, I think, probably, for what this thing is actually specifying. So if you look at the align point themselves, if I go over to the file format and we look at the align point, there it is. You can see we've got, the p% values, the size value, and the type value. I don't really think we need the size or the type for the font, so we're really just storing two U16s. I think that's it. So what I'd like to do here is in that font HHT, I think I'm just gonna literally store the two U16s and then assume the rest of the align point values. I think that's what I would like. So when we actually do this, let's grab all the tokens that we actually need. So we've got a name token, or sorry, I should say a file name token. We need this to have a comma. And this is just going to be a giant list of requirements, right? So we're basically saying, look, we need a file name, then we're going to need, and I mean, I guess I don't even need the word token after it. I could just say that's the file name. And then when we actually go to pass this thing, I can just say like, oh, all right, well, it's just, it's whatever the value is. I don't remember in the tokenizer exactly what that field is called. It's just text, right? So here we know we're going to get the file name. We know we're going to get the code point. And then we're going to get the align X and the align Y. And that's the entirety of one of these font specifiers. So it's just the file name, the code point, the align X, and the align Y. Those will all get writ in, and they're not going to get written as float because float is just dicier to deal with, so I'd rather not, right? So after all of that, we should just be able to validate, like, whether the glyph index is what we thought it should be, and so on. I could even do this. Right? And so if I do that, then when we look at how those align points are actually packed, when we put those together, we can just make sure that those values are within range. So what I can do is say, if the code point, well, the code point doesn't really matter. If the align X is less than this and align Y is less than this, right? Do we not have an S16 max? We do not. We have a U16 max. But I guess that's what we actually meant. So we just check to see, make sure these are within the ranges that they're allowed to be. If they're not, we'll issue an error there. And if they are, we're good to go. We also want to do a check for the glyph. Just massaging this code around here. So this is also an error. And so here what we want to say is, all right, if the token there we go. if the glyph index for the token is wrong, and in here, just looking at it, I think I want the token itself just for error reporting purposes, right? So I think I want to do this. I want to be able to report that error specifically on that token. So I want to be able to say, like, look, if the glyph was out of bounds, there's the error, right? Like, something like that. I don't know if we need... Do we actually use carriage returns? No, we don't. So I can get rid of that. And so here where we have those errors, I'm just going to give it all of the numbers we know. So, you know, here's our glyph index and here's our glyph count. So that way it should be obvious, like, hey, something specifying like an out of range glyph, and we can't. We don't know what to do with that. Like, it's obviously corrupt font markup rather. So, you know, fix it. So here we also want sort of the same thing. We want to be able to specify the alignment being broken. And so in here, I probably want this to be the align token as well. I don't know exactly where we want to error out on this. We could error out on either one individually, but I don't actually know if I care about that. So we may just, maybe we'll use the same thing here and just say glyph has bad alignment values. And again, we really don't expect ever to hit these, but we'll just, you know, leave them there just in case. So assuming everything comes in okay, then we can set the code point to be correct, which is what we want. And we can set the alignment to be what we want. So this align point, for example, we can set up here. And so the align point has to be set to probably default, right? So up here we probably want to say, look, the type of this thing is that. And then here we want to set the p% and the size and stuff like that, right? So actually, you know what probably I'd like to do is just do one of those set align point calls like this. And say, all right, set this align point to be aligned to this. It's not going to be, well, yeah, it is a 2-parent, right? The size is going to be 1.0. And the alignment in terms of like where the point is going to be the center point. And then we will overwrite that, assuming that we see one of these other alignments here. We'll overwrite the p% with the values that we actually get. Right? So that allows us to import the entire thing in here. And then all we really need to do is start to take out some of that bitmap code so we can call it and say, hey, we need to import this like dependent bitmap. So please make sure you get it. And when we get it back, by the way, I need to know the bitmap, right? Because this right here needs to be set. So we'll set the code points .glyphindex Unicode code point here, and then we'll set the code points bitmap here. Right? So that's the way that's got to work, I think. So we'll expect import glyph to tell us what that's going to be. Then finally, when we get to the very end of it all, down here, and we're ready to write everything back, we can create the font pretty easily now, but we need some way of like applying tags to it, because remember we got like a tag array and stuff, so we're like, you know, we're going to have to actually do some work here to tag the metadata and that sort of thing. And so if we look down at what we're actually doing here when we do all this processing, you can see we can call update asset metadata, right? And that would actually do what we need. Like, you know, if you look at this, it sets the type and diffs the tags and all that nonsense. We need to do that, right? So that pretty much takes care of that matching for us. So I think that part is pretty good to go, right? What I don't actually know is where is it getting the data for the actual where is it getting the data for the actual asset? So it looks like it's just using it, the asset index right here. Okay. Like that seems totally fine. So I think what we want to do, yeah, I think I'm right. I think what we want to do is just break this out. And this call just needs a version that doesn't use a grid, that's just going to do one asset, and update it that way. So if we imagine we were inside here, what would we need? So if this went away, right? So this thing has to call out to, you know, some other function here, right? It's going to call this thing. What else does it actually need to know in order to produce that result, right? And so from looking at it, it seems pretty clear, well, it needs, you know, all of the stuff that we were giving it here, right? The assets, the file, and the fields. What we really need to do now is say, well, we know that we're not taking a tag grid, so we can't pass that. And we do know that we want append tags, because obviously that needs to go down there. But we also need to pass the grid tags and the asset index, right? Because those are the parts that came out of this. We should probably also pass, well, actually, I think that just comes out here, right? So if we did that, so now we've got the asset index here, and we've got the import tag array tags here. I think that allows us to make a call to just update a single asset's metadata in the case where we are only doing one, which is like what we have with the fonts, where parse font block, for example. When we get down here, we want to do that update asset metadata like so, right? So we know we've got the game assets here. We know we have to pass a source file of some kind, so we don't know what that is yet. We're going to have to get it. We should have the fields, because those exist already. We know what the append tags are, so those are fine. And I don't think we have this, because this came from the grid. So these extra tags just aren't, they don't exist, right? So I think we're down to just this. We need to be able to produce the source file that this stuff comes from. Unfortunately, we don't have one. So I'm not really sure how we would do that. Because fonts don't come from a file. It's this file, which I guess is okay if we wanted to specify that. So let's just take a look at where that's actually happening. So file arrow, right? It's really just used. It's really just used to get that destination file index, which I think we already know, right? So So do we actually, if we were to get rid of this, well, let's build first and go from there. And so I can use some errors to guide us in this process a little bit. All right. So this is actually import like grid tag, right? So that was wrong. Or grid tags, I think. This needs to be told what kind of field it was there. This is probably the wrong format. What's our push array call again? It's the arena, the count, and then the type. So it looks like this. It's the horror of capitalization. I don't know if code point should be intercapped or not. So I think the main problem, just looking at it here, what we're running into, is the fact that fonts don't come from a file at the moment. They're just reading out of the HHT, and the HHT always gets parsed. So in a sense, we don't really need to do the checking that we normally do because we're always going to effectively have an updated version. So it's just if they diffed, they need to be outputted. If they didn't diff, they don't. But we don't need to first check that piece of information because they don't have an additional file that we read. So that's the part we're going to have to work around. That's really just a plumbing problem, I think. So we can kind of go from there. Quickly, let me just sort of clean up any other errors we have. So we don't really have many. It looks like we fixed them. So that's the part that I need to kind of get away from here. So update single asset metadata. Let me just look now at what I wanted to look at before. So let's suppose that asset source file was not available. And or asset file wasn't available. Like, what are these things actually being used for, right? So first of all, there's the modified value, right? And then there's a writing out. But that we know because we know which asset file we're writing to. That's something we could just supply. So what if we said this, where we're like, all right, that goes back here where it was, and then this actually passes asset file, right? So it doesn't have the other file, it just has the asset file. What would we then not know, right? Like what is the problem there out of that? So first of all, it looks like we don't know where to put the errors. So we could, I mean, obviously we can't fix that. Why can I not go backwards? Oh, there we go. All right, never mind. It looks like we don't know how to put the source file in there, so that would be fine. We just need to pass that, would be the name of the HHT, which is fine. So really it looks like mostly what we're talking about here is just the error stream. It's just the error stream and the name. So again, seems pretty straightforward. What we can do there is say, all right, like pass the error stream and the source file name. right? So if we did that, then we could take these out and just say like the error stream there, I guess we'll call this errors for simplicity. That should allow us to say, okay, if we pass those two things out from inside update asset metadata, so that when we look in here and we're sort of sending this nonsense down right there, after the asset file, we'll send the base name and we'll send the errors. I think like that. Then in here, we would not have to do this anymore. All of these things would just go to stuff that we pass directly, and then we don't have to worry about it. What did I call that? There. And so that way, that should give us the ability to, when we call update single asset metadata here, we only need to pass like the destination file and what that name would be. So I think that's okay. Like that seems like that would work. I don't really see any issues with that. So when we come through here, we know which asset file we are, because this operation we can do right in line. So if we get to here, we can grab that by saying whatever the context HHA index is. That should give us the asset file that we're targeting. The error stream probably would just be the tokenizer's error stream. So, the tokenizer itself, right, has an error stream built into it that it's using. That's the one we would route all of our errors to. So in here, we would just need to say, okay, pass the asset file, pass the error stream from the tokenizer, and then the only thing we would need is that base name. The base name itself, I think, is just this. So I think the context itself has that piece of information. And I think that's everything that we actually need, right? Pretty sure anyway. So when we call this, we need to get the game assets. We already have them. They're just not put into a convenient pointer. So, pretty trivial there. The only other stuff we now need to think about is how we're actually going to update the rest of the font info. I think most of it is otherwise fine. Contents is undeclared identifier. That's true. I don't know why I said contents. And this is the part where now we need to figure out what the asset index actually is going to be. Okay. So now I think we've come to the only hard problem that we actually have, and it is as follows. Normally, we use the, normally we have a way of looking up what the asset index was for the import on a particular file. But in this case, we don't know, right? Like, we have no idea what the asset index actually was, because we don't have anywhere to put it, right? So we've got a couple different ways we could do this. One is that we could introduce something into the asset system that itself stores the piece of information we needed. Like, hey, there's a way to look up a font, an asset name, and back comes the index for that asset, right? So there's an additional lookup. I don't love that because we're introducing a code path just for the font handle, which seems less good, right? But my assumption here is that we would rather go with something simpler. So I'm thinking maybe what we would do is when we load the glyphs, instead of getting back to bitmap ID, maybe that import glyph routine actually gives us back one of these. Right? And we could store the font index in there. Just a thought. The reason that I don't love that is because it wouldn't allow you to use the same font glyph in multiple fonts, which seems like a bad limitation. So I'm just not sure exactly where I'm just not sure exactly where that data should come from. It seems like we do want to support the idea that you can have multiple of these, but I'm just not sure where I would put the information. I really don't have a good idea for this, sorry. So I guess when we, oh wait. Maybe I do have an idea. You know what? I do have an idea. I take it all back. This is actually much simpler. All we have to do is introduce a synthetic asset file, because the asset files are stored in the HHAs that they are packed into. So actually, it's not that hard. All we have to do is say, in the asset system, when we actually initialize one of the sources, right? This code, we just use the base name of the font. So I don't know why I was making such a big deal out of that, because actually it's really just not that hard. All we have to do is say, all right, get us, font source file. This is synthetic, doesn't actually exist. There is no actual source file, but that's fine. We don't care. We pass the game assets and the base name. The base name is whatever that block token, whatever the name is that we get out of here. So before the open brace, right, I just forgot that we have this. There is a name. This is the font name, right? So that font name should give us the asset source file we need. So here I'm going to say get the source file for this thing, and then from there we can create our font asset and do all the rest of our work. So it really wasn't that hard after all. We were just being dumb. So sorry about that. All right. So then in here where we've got the font source file, we can now actually use this. There we go. What we want to do here is do that remapping. So like where we actually set the target of this thing, you can see it here, right? Where we say, where is this thing going to go? You know, it's going to go in here or whatever, right? So this is all we're going to do. We're just going to say, yep, let's go ahead and write that into the asset file, or asset source file, I should say. So whatever this font source file is here, you know, it's going to be written to this HHA now mandatorily. That's where it goes, right? And once we do this process, this asset file will now have the asset index in it as well, so we can look that up. Of course, that asset file index has to be updated. I think now we can move that logic, though, back into the single writer and just have that be handled in a common case. So here you can see us doing this part here where you get the asset index out of the file and doing the tags. So I guess it was done somewhere else. Where is that somewhere else? So I guess it's just in all of these, right? Where you see it says like, hey, get me the asset index. So this is where it's been happening, right? It tries to get out of the asset file whatever the asset index was. We either use it or don't. So I think this is fine. The only thing I don't know of here is like when this asset data gets updated, I am assuming that that means we need to mark it as modified, but I guess that would happen with the tags anyway. So I think we're fine. So I think all we need to do here is just say, all right, we've got the HHA font information. That's just a 0 thing that we're going to fill out in a second. When we finish that can just be read out of the asset, I guess. I think that's all we need. So we just say, look, is there already one for this thing? It's going to be in the 00 slot because there's only one for a font. If we don't have one, let's reserve one for the font. Once we do, we're good to go. So we've got the asset loaded out now. So that means the font is just the asset font. We write all the data into that, and then we can update it and be done, right? So I think that's everything we need to do modulo actually writing out the new asset metadata, like the glyphs and that stuff. So we do still need to do that one part, but otherwise I think we're okay. The fact that this requires a char star is bad, and we'll have to fix that in a second because we want to be able to not do that. I'm surprised we're still doing that, honestly. So I'm not sure what's going on there, but we'll see in a second. So the HHA index here, that still comes out of the context. I'm not sure why we're doing that. This here is the font source file. Oh God. Looks like I've... Don't ask me why some kind of weird screenshot just happened. All right. So, yeah. So the asset, we actually want to look at the HHA part of the font, obviously. But I think that's it. So now we just have to look at update single asset metadata. Make sure we're passing the right stuff. We need the assets, the asset file, the base name, the errors, the fields, the append tags, the asset index, and the extra tags. And then I think we're just about good. Right? Seems good. So that update single asset metadata part there, I guess I'm not sure what that's complaining about. We've got the asset, got the asset file, we've got the HSystem, the error stream, we've got the fields. Oh, that's the problem. All right. So I think we need to actually now just do 2 more steps. One is to write the actual glyph import, which is really just fixing our existing code so that it can get munged. We can just reuse the stuff we already used for loading a bitmap. But the thing we need to do here is we don't currently write out our two arrays. So we need to reserve space for those and write them out if they don't differ. So right now, what we know is, you know, in this case here, we could do this, right? And test to see if what's already in the file differs or not. And that's sort of what we need to do here. Another way to do this would just be like, okay, oops, sorry. So what we need to do now, you know, when we grab this font out, we would also need to do a thing where we say, hey, make sure we compare the existing font arrays that are in the existing font data. We need to make sure that those are not different than the ones we just computed, right? So how we actually do that, in this case, it's a little bit tricky because we don't know whether or not we don't really know that those fonts have even been loaded. So we would have to compare it with the file directly, right? Because if you look at what actually happens when you do a load font, you can see right here, like, that's not what I was talking about. When you do a load font, you can see that it actually has to page in that code point data, and we need to be able to know what's happening there, right? We have to be able to compare that existing file data to know whether we need to rewrite it. You know what I'm saying? So I think we're probably looking at something where we would need to do like literally this load. So we would need to do something like, okay, assuming that we think we don't need to update, what we need to do here is make sure we can actually load the file in, right? Get this data, and then do like a compare, right, on that data. And looking at the way that this stuff works here, where we get the size total, I feel like we almost want to make this code be shareable so that effectively what we can do is do this the same way this is doing it, and make sure we fill those the way they're being filled here, something like that, so that we can actually test them later. I don't know. It's kind of hard to say. But I suppose the other way to do it is to read them separately and then test them. I don't know. Again, it's really annoying. This is, as you can see by the amount of work we've had to do for asset importing, the difference between an asset system that allows dynamic updating and running from pack files that can be updated directly, the difference between that and the stupid version, which is just I can only read things once and pack them once and there's no dynamic updating, is massive, right? It's like a 10x complexity increase to go from I don't support hot updating of the live files to I do. Because 90% of this code is from that, right? But that's why people license engines or buy asset system stuff, like I used to work on, because it's a tremendous amount of bookkeeping code, just way too much. And most of it's just because art tools aren't made to output things games can run on directly, so you're doing this work every time. Or the engine writer is, but somebody is, because the tools don't do it. So anyway, we need some way of knowing whether we need to rewrite it, because we don't really want to rewrite it every time we process an import. We only want to rewrite it if we actually got different values than the ones that we already stored. So what we'd like to do is say, compare those two things. What I might say is like, let's just do this. So we need to do a full rebuild if we do, or if blocks in the file, the two blocks in the file that we actually have, if those blocks differ. And so if the asset, here we just do this, right? Like assets, asset file. Here we just say, look, let's write a function that takes an asset file, takes a range of data in the asset file, and then an actual array we would be writing out, right? Like the code points or the horizontal advance in our case, and just returns whether or not we need to. So basically that way we can just do something like this. So we now know, like, all right, we know that we've got the code point size and the horizontal advance size. We know we need to diff those ranges out. Here's what we're going to be writing to them if we need to. Let's make something that can actually do that. Then we'll say, all right, if we need a full rebuild, then we need to actually reserve that space. Otherwise, we don't actually have to do that, right? We don't actually have to rewrite the font if those things didn't change, because those are the only things that actually would have depended on this, right? So I think we should be able to do that, I'm guessing. That would seem logical to me. But like I said, I'm not 100% certain. So the other thing we might have to do there is we might have to compare these as well. So yeah, I mean, another thing we might want to do is say, okay, if any of these things differed, we also need a full rebuild. So that's just another annoying piece of nonsense. Again, this is where I think I kind of want to be able to do something where I say, here's the data we would write just in its entirety, and we just like write it, and then there's a diff that I put in a to-do basically exactly like this. You can see why. It's just this is very, very annoying and complicated, and I feel like we could have gotten it better. I don't really want to have to go down that road now, but I do feel like there's something there. And so if this were like my day job, I would definitely go in and figure out how to make that happen. But, it's not, so we won't. Something like that. You know what I'm saying? That seems reasonable. Not great, but reasonable. Hello. Cat is back. So I think all that's good. I just now need something that says what the sizes of these things are, which we kind of already know, right? So this is how big the code point size is. This is how big horizontal advanced size is. And although I don't love that, I think that probably is fine for our purposes. Again, this is not code that users would be running, so if it is kind of janky or fragile or we have to debug it a bunch, it's not as bad because we don't actually depend on it to be reliable when we ship it. That helps a little bit, but again, like I said, it doesn't really meet kind of my I would do another round on it, I guess is what I'd say. So looking at this, we then, if we need to do the rebuild here, I think really when I'm saying that, I suppose this stuff can all happen just in general, that stuff is fine. So what we're really looking at here is in needs full rebuild. That's just when we need to actually write the font out itself. And so to do that, we just need to follow the sort of the lead of the reserve asset, like space or whatever we call that. Let me just jump to reserve asset. We just need to do this, where we reserve space for each of these things. Now, I guess we don't do it twice because we just do it for the total size that we needed. So what we would be doing here is saying that asset data, so this, excuse me. This asset data that we've got here, we need to make sure that that's going to hold the entirety of what we're going to write. So we have to pass it the data size of the code point size plus the horizontal advance size. Once we know that that's safe, we're good to go. But there's sort of one additional thing here too, I suppose. This needs to be checked as well. So we sort of need this to have been computed already as a, sort of a secondary piece of information. Right? And so if the data size was wrong, or these things don't match, or the blocks themselves don't match, if any of those things is true, we need to just rewrite this thing. And so that's going to set the modified stuff on these files. And that'll happen automatically, which is nice, right? You can kind of see that happening here. Why this doesn't set modified, I'm not entirely sure, but oh well. And then anyway, we at that point need to write these out, which is fortunately not so difficult. We know that we've got the code point size here. I guess I'm going to have to make these be 32s here. We don't support larger than 32 size for that data. So when we write the asset data out here, what we would do is say, here's the asset file in question. Here's the data offset. Here's the thing we're writing. Oops. Go ahead and write that. I think it's that. And then we've got horizontal advance size. Horizontal advance. Now, this is going to start where the code points left off, but other than that, I think we're okay. That'll do all the writing for us, and off we go. Again, not pretty, but I think that's where we're at. So that will write the font stuff out, and looks like we got one too many close parens there. Looks all good. And then we need to actually implement that block differs routines, which doesn't look particularly hard to write either, so that should be pretty easy. And then we can just focus next weekend, I guess, on what is this complaining about? Connect import grid tag, no user-defined configuration available. Argument 8, tag array to grid tag. So let's just quickly blast this in here if we have a comparator here for a block, then what we want to do is say, here's the game assets, here's the asset file, here's the data offset, and the size, and then the, I guess what we're comparing it to, right? So we need to do that read, and then we need to do a mem compare, which I thought we had. Don't we have something that does this? I feel like we wrote something like this. Aha. So we have something that says whether the memory differs or not, and that's what we actually need in this case. So we should be able to do a memory is equal call where we pass the buffer, the file value, and the test value, I guess, are the two things. We should be able to say that gives us our result. So the only thing we have to worry about is how we would actually, how to actually get that data out of the file. So in order to do that, I'm just going to go and, again, look at that part that we were just, for the load font call that I was looking at before. We're just going to do that same operation. So we say, look, assume the result is false. Try to get the, for whatever the asset is that we're reading here. So I guess we could just pass the asset, actually, because it looks like the asset itself has the file index in it. So we could even just do this, right? But I don't know. I'm going to go with this. For this asset, get the file handle that we're going to use to load it. For the data offset that you're given, go ahead and read that from that file handle, however much we told you to, and put that into our temp buffer. Assuming that there weren't any errors, then go ahead and do the compare, otherwise assume that it failed. Now, when we do this, we're going to need a place to put this, basically temporary. And so what we'd like to do here is we'd like to just be able to have a scratch, right? We'd like to be able to do something where we just say temporary memory, like begin temp, temporary memory. Because we don't care about saving any of this. We just want to use it just for scratch. So we should be able to do that just fine here. And that means we should be able to allocate basically a mem block to use in this particular circumstance. So in order to get that file value, we can just do give me something that's the size you said we needed. We don't need to do anything else with it. We also don't need to clear it like we normally do. So we can just say, hey, don't clear that either. So that's pretty much the entirety of the block clears or block differs call. We know we've got a temp arena here because there's just one sitting around. So we can just say whatever that temp mem was called, temp arena. That should do it. So I think that gives us the full pipeline pretty much from start to finish. Looks like get file handle for is not pre-declared, so we're gonna have to push that out there. We need a version of get of that get or create asset source file that doesn't use a char star. So I'm not sure why it's even using a char star actually. because that's kind of annoying. We want those to be using a name that's a string. So I think that's like an older piece of code. So we do want to fix that. But what else do we got here? And then we have to implement the import glyph there. Let's look at what's the problem is here, asset file to asset. So in this case, we know that it's just this asset. When we're creating this asset, we need to set the asset file. So when the asset gets reserved, I'm not sure when this asset file actually is supposed to get set, when the asset's supposed to get set. So like when you do this reserve, it doesn't actually set the asset to anything in particular. So I'm curious to know like when that piece of information actually gets set, because we need it to be reliable. If you look in here, you can see that it's got like a file index and an asset index in file. And so I do not know who's actually setting those things. So that's only happening like out here in write modifications to HHA. So I do feel like that means that that buffer check has to take something more specific. So here in get file handle 4, what we really need to do is just get this platform file handle. So I think what I'd want to do is inside block differs, just forget all of this garbage entirely, and actually just do this. Right? Because we already have the asset file in question when we're here. So rather than going through some roundabout process to figure out what file we're going through, what I would much rather do is in here say, by the way, the asset file in question is this one. Here's the handle. You know what I'm saying? All right. Let's see here. So I think that's it. I'm still a little cagey on how this works. How does it know where to put these assets? So like who is setting that? Asset index and file is getting set there, but file index, someone has to set this. Right? And that someone is kind of us. Right? So, I mean, that just kind of has to happen. So I think we're okay. So I think that's basically it. Again, very, very complicated. Lots of pretty tricky stuff happening there. And again, I think if we wanted to do another full pass on the asset system, we could fix a lot of that. I just don't know that we will. Because going to a system that's more generic in terms of how it prepares and then diffs data is almost certainly the right way to go. But we probably just won't do that. But that's how we would do the next iteration to make further improvements. So for right now, what I'm going to do is I'm going to finish up for today because we're pretty much done. We just now need to stub out the import glyph call, which we don't actually have. So it's probably just a U32 there. And yeah, that's, I don't actually know what we want to pass there yet. So that's what we need to implement, but at the moment, it's not. And then the only other thing that we have here is we want to be able to do a get or create asset source file without needing a null terminated string. I am surprised that that didn't already exist. That's really bizarre. You can see here, like, you know, it's just, yeah. Just looking at all the places it's actually used. So you can even see in here, like, we had to do a null terminator on here for no reason, right? So that we could pass it as a null terminated string to begin with. So I really do think we just want that to be a string in general. I mean, that's really all there is to it. So I think we do want that. I'm going to go ahead and make this happen this way temporarily. And this will just make sure we compile okay for now. So what was it supposed to be taking there on the bitmap ID? Because that's the only thing we've got left. Oh, it is actually, it's just an actual bitmap ID. Which is kind of a little bit weird, because we don't really use IDs in here otherwise. So I don't love that. I think we want that to be a U32. You know, not that that's not what it is, but I just think that should be like that, right? So I think that's good for now. That leaves us running okay. So I think that's pretty much all there is to it. We can go ahead to brief Q&A now. And next time we'll do the import glyph. Next week I'll do import glyph and debugging. Import glyph will just be like basically remunging some code there. Oh, sorry, did I have a typo there? Let me take a look. Yeah. Looks like no questions. All right, if we got no questions, then I am done. I will go ahead and wrap it up. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can follow along at home. That's it for this weekend. Next weekend, I will just be doing cleanup work so that we can check this off, the asset system off as being done. Basically, that involves pulling out that bitmap import code so that it can work for glyphs or for sprite sheets like it was working currently. And then just like testing everything, debugging, you know, making sure we can rebuild the art assets, just putting it through its paces, making sure everything's fine. And then I think we're in good shape. Hope to see you back here for that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.